Let's take a look at the molecular geometry for SiO4 4-. This is the silicate anion. So we'll start with the Lewis structure, and we can see we have this central atom, this Si here, and we have 1, 2, 3, 4 atoms bonded to it, and there's no lone pairs. So we have 4 things bonded to it. That means we have a steric number of 4, and we don't have any lone pairs. It's going to have a tetrahedral molecular geometry, and the bond angles will be about 109.5. Let's take a look at that in 3 dimensions. So this central atom here, the purple, you can consider that to be the Si. We're going to add 4 oxygen atoms. 1, 2, you see them spreading out. 3 still spreading out, and the last one 4. And this gives us what we call a tetrahedral molecular geometry. If we wanted to look at the bond angles, it'd be about 109.5. So the molecular geometry for SiO4 4-, the silicate ion, that's tetrahedral. The electron geometry, that would also be tetrahedral because we don't have any lone pairs here on the central atom. Let's go back to our structure. So you could also use the AXE notation to figure this out. A is the central atom, that's the Si. X, that's the number of atoms bonded, 1, 2, 3, 4. And then E, those are the lone pairs around that central atom. Since there aren't any lone pairs or unbonded pairs on the Si, we could just say that E is 0, but usually we just don't write it. So if we looked up AX4 on a table of molecular geometries, you'd see that it's tetrahedral, just like we found before. This is Dr. B with the molecular geometry for SiO4 4-. Thanks for watching.